Freshwater production on board ships. Let's see why we need freshwater generator on board. To supply all the potable water needs on board. To supply water for boiler as make-up feed. Large freshwater tank is not necessary on board. Taking questionable quality of potable water at ports of call is not necessary. A vacuum is any pressure less than the local atmospheric pressure. 1 atm is equal to 760 mm of mercury. If we reduce the atmospheric pressure, that mean build-up of vacuum, the height of mercury column will be drop accordingly. Sensible heat is that heat when transferred to a substance, the temperature only changes, but there is no physical change of state. When liquid is heated, its sensible heat increases. Finally its temperature is reached, at which the liquid begins to boil. Latent heat is the heat, when added or removed from a substance, it will change the physical state, without a change in temperature. Boiling temperature depends on the pressure acting on the liquid. For an example, at 1 bar pressure, water starts to boil at 100 Celsius. If pressure increases more than 1 bar, boiling temperature increases more than 100 Celsius. Same way if vacuum is applied to the water, it will boil at below 100 Celsius. Basically there are two methods of making fresh water on board. They are distillation method and reverse osmosis method. In distillation method boiling and condensation is carried out to make fresh water. The vapor produced by boiling seawater is condensed by cooling. Most of the freshwater generators are flash type. These operate on principle that the boiling temperature of water varies with pressure. Reverse osmosis is a water treatment process that removes ions and particles in water by using pressure to force water molecules through a semi-permeable membrane. During this process, the particles are filtered out, leaving clean water. Shell and tube type freshwater generator. Engine jacket cooling water is fed to the heater, where it circulates outside the tubes. Seawater feed passes through the inside of the tubes. Pressure inside this is maintained in a vacuum condition by the ejector, and the reduction in pressure results in some seawater to flash off into vapor. The remaining brine is taken out through ejector. The vapor rising up through the demister, and condensed by the condenser. The condensate is collected in the tray, and fed to the distillate pump. The salinity of the distillate is monitored, and once it falls to a preset value, the three-way valve will open the path to the freshwater storage tank. Starting of shell and tube type freshwater generator. Set the valves of ejector pump system, and start the pump. Make sure the vacuum breakers is shut, and inlet and outlet valves to the condenser are opened. Adjust the feed water flow to the plant as given in the manual. Allow vacuum to build up in the evaporator. Once vacuum is built up as required, heating to the heater can be opened slowly, because the heater acts as another jacket water cooler. Slow opening of valves will give some period of time to the jacket water temperature controller to adjust jacket temperature in main engine system. Switch on the salinometer. Open the valves to fresh water tanks and starts the distillate pump. Once the salinity level falls to preset value, three-way valve will open to fresh water storage tank. Plate type freshwater generator. The principle is same as the shell and tube type, the construction is the only difference here. Seawater enter into the condenser plate stack, and cooling the water vapor. As a result, fresh water is made there in the condenser. After the condenser, some amount of seawater feed into the evaporator plate stack. It is heated by the jacket water, and some of seawater flashing out and pass through the demister into the condenser. Brine and non-condensable gases are extracted by the ejector. Starting procedure of plate type freshwater generator. Open valves on the suction and discharge sides of the ejector pump. Open overboard valve for ejector. Close the air screw on the shell. Start ejector pump and wait until pressure drops down. Once vacuum built up as required, slowly open jacket water into the evaporator. Now the boiling water temperature rises while the obtained vacuum drops little. This will indicates the start of evaporation. Switch on the salinometer and open valves to fresh water tank. Start the distillate pump. Pay attention to the parameters. Adductor. Adductors are devices employed to remove air and liquid from the systems. In freshwater generator, they are used to bring the pressure down, as well as removing the brine. Fast-flowing seawater goes through a pipe that tapers at one end. The tapering causes a drop in pressure which sucks air or liquid into the adductor. The adductor will discharge both air or liquid at the outlet. Demister. This consists of stack of wire gauze. Water vapor and seawater droplets move upwards together. Steam passes through the demister. Seawater droplets trap in demister and drain. Reverse osmosis. Reverse osmosis is a filtration method that removes many types of large molecules and ions from solutions by applying pressure to the solution when it is on one side of a semi-permeable membrane. Let's see it detail-wise. Osmosis is a phenomenon of liquid flow from a low-density to high-density solution through a semi-permeable membrane. If we consider a vessel filled with seawater and fresh water, separated using a semi-permeable membrane, a pressure is created which will force the pure water to flow through the membrane to the salt water side. If we apply a pressure to the salt water, same as osmotic pressure, the flow through the membrane from fresh water to seawater will cease. If a greater pressure than the osmotic pressure is applied, the flow will be reversed. This is called reverse osmosis. A reverse osmosis system removes sediment and chlorine from water, with a pre-filter, before it forces water through a semi-permeable membrane to remove dissolved solids. After water exits the semi-permeable membrane, it passes through a post-filter to polish the drinking water before it enters a dedicated faucet. Reverse osmosis systems have various stages depending on their number of pre-filters and post-filters. Every reverse osmosis water system contains a sediment filter and a carbon filter in addition to the semi-permeable membrane. The filters are called either pre-filters or post-filters, depending on whether water passes through them, before or after it passes through the membrane. Each type of system contains one or more of the following filters. Sediment filter reduces particles like dirt, dust, and rust. Carbon filter reduces volatile organic compounds, chlorine. Semi-permeable membrane removes most of total dissolved solids. Thank you for watching. See you in my next video.